I don't want to say a lot of things about him. We had a short interview, and it turned out that, okay, he's coming from the Netherlands. He's a leader he's technology leader in an AI company, which also deals with big data. But a fun fact of him, that he is collecting and repairing vintage motorcycles. His oldest one is 52 years old, and he's also riding it, so be careful. And please welcome on stage with a huge applause, Bas Geerdink, the culture, architecture, and technology of MLOps, how to do machine learning in production at enterprise scale.
Hey, thank you. Thank you very much. Thanks. Well, thanks about the fun fact about the motorcycles, but that's true. I like to ride and restore old motorcycles. So if you want to chat without a screen or a technology topic, then please reach out to me. Jo regarde. Okay. Goedemorgen. Any Dutch people here? Goedemorgen. And good morning to the rest of you. We're going to talk about MLOps, machine learning operations, and how to do machine learning in production. My name is Bas Geerdink. I'm from the Netherlands. You know all about me already through this nice introduction. And you can find me on LinkedIn, etc. I will be happy to connect. I also wrote a couple of resources like books and blogs, etc. about this topic. And that's basically what I do. I advise organizations in how to do machine learning in production, because a lot of people are struggling with that a little bit. And I'm sharing my experience to you today. Any data scientists here in the room? Who's a data scientist? One, a few of them. Great. Thank you guys for giving us a lot of extra problems and challenges, right? Because since a couple of years, we have a new field of research, and all people from university learning all kinds of fancy new algorithms and tools and frameworks. Actually, I was also trained as a data scientist, but it was 20 years ago. And then, people didn't really bother, right? They put the data scientist in a corner somewhere. If they even did anything like that, it usually was just limited to academics. But now, we have to do it in an enterprise. So these data scientists, they are very smart and very good people to build these kind of algorithms. That's what they learned to do at university. So what they come up with is this, usually, right? This is a notebook, a Jupyter notebook, that contains source code, but it's actually, it's usually stored in the laptop or maybe luckily in a Git repo of a data scientist. And this contains your model and it makes predictions. So that's great. But how do you work with this, right? How do you put this in production? How do you operationalize this? It feels a bit like the old Excel that we sometimes have still in organizations. So actually, there's people that make a statement that Jupyter might be the new Excel. So we have to be a bit careful there, right? Because before you know, you end up with a lot of Jupyter notebook files that are in somebody's laptop somewhere, and only one person knows how to operate it. But it is crucial for your organization because it makes such great predictions. So to prevent that, we have MLOps to the rescue. Because we should realize first that this data science code is important and it is well structured, etc. But it's only a small part of doing machine learning. And in an article already in 2015, this was recognized. This little black box that you see in the center, well, my laser is not pointing it out, but you see it. That is the notebook that I just talked about. And it might be a notebook, it might also just be another part of a source code file, a Python file, something else. It's only, it has to be integrated in the rest of your landscape. So all the rest of the tooling, data, etc., that goes around it should also be recognized, and you have to manage that. luckily, there's tools for that, right? We have, yeah, and you've seen a few of them already in the conference yesterday and today. So luckily, there's a whole industry for tooling for AI. And if you go to a website called the AI Infrastructure Alliance, which is a good website, you'll see some of them mentioned. But this is just the letter A. So that's the first. I could have implemented a scrollable page here. Sorry for my technical limitations. But you can imagine how long this list is for the tools that we have in the AI landscape. And they are nicely segmented in all the things that we need to do. But yeah, how do you make sense of this? Where do you start? Which tool do you pick? It's going to help you a little bit with that. But first of all, it's not about the tooling at all, actually. If you want to put machine learning models in production, it's more about way of working, cooperating, people. It's a paradigm. So MLOps is actually DevOps, but then extended to machine learning. MLOps is about gaining trust and speed when you're building machine learning models in the same way that we did DevOps like 10 years ago or so. I think then it was introduced like 10 years ago and was operationalized. So back then we said, hey, why don't we break down the silos of developers and operations that throw things over the wall? Why don't you combine them in one multidisciplinary team, and they are jointly responsible for a piece of software? And that was a revelation, and it was a great insight, and that's how most organizations operate nowadays. And actually, some of the roles that we had previously were merging actually together. But instead of you are only responsible for developing code or only responsible for maintaining it, now you have a joint responsibility. So you're like a DevOps engineer. And yeah, that makes sense, right? You build something, you run it. Eh? That's your shared responsibility. MLOps is extending that a bit and so we should probably call it ML DevOps, or maybe including business in the mix, but that all becomes too big to pronounce. Anyway, MLOps is the same as DevOps, only we add machine learning to this. So these data scientists that also are here today should not be in a separate corner of your organization. They should be in your teams, working together closely with the DevOps engineers that you already have, and with the business people. But of course, there are some specialties. The data scientists are trained to build and train machine learning algorithms. The dev and ops engineers also specialize in a certain craft. They know how to build and maintain software. The data engineers are good in building data pipelines and extracting data and transforming data, etc. There's also the new role emerging of it, machine learning engineer. People that are specialized in using tools and frameworks to put the models into production. And this all seems complicated and difficult to implement. And in a way, it might be, but you also should recognize that these are just roles that you take up in your team. This is the task that you need to do when you want to operationalize machine learning models. But it doesn't have to be 5 different people, right? Same as I just mentioned, the merging of the DevOps engineer. You can also do this with this kind of roles. That could be a perfect person that fills the role of data scientist, but also does a lot of the machine learning engineering tasks. Or a data engineer that is actually doing a lot of operational stuff, operational work. As long as you recognize that this is the work that you need to do to put machine learning models in production, then you're good. Okay, so that's the cultural team part of it. First thing to recognize. Now we're going to switch to the architecture, and after that I'm going to tell a bit about the tooling, because I think it's actually least important. So you have this notebook, you have an algorithm that makes some kind of predictions. How do you put this in production? Well, the first thing is that you probably need to have to incorporate it in your business, right? Because if it's running in a notebook and it's making some predictions, then it's not really useful. So it has to be incorporated into a business process. Let's take the example of a model that forecasts what customers will be buying next in a retail organization. So you have a website, customers are shopping online, and you want to give them a good prediction to make more money, sell more stuff, right? So you show them actually a prediction what they are interested in, and that is a recommendation. Well, that needs to be incorporated in your website, right? Because else it's useless. So what you usually do is you wrap that model in a kind of an API. So the API is called from your website. So the app that you use, that's the website, needs to call the API and actually show the results back to the customers. That is usually not a direct connection. There needs to be some data preparation and post-processing to make this happen. Why? Because your model usually gives a prediction that is not interpretable. So your model gives, for example, a score from 0 to 1. Yeah, that's useless, of course, if you don't know what to do with it. If your model gives the recommendation 0.7, yeah, what is that? That's probably, you have to compare that to a certain threshold or to other forecasts, so what to show to the customer. And that's the post-processing part. And the same goes for the preparation part. Your model accepts features that are not directly available in your app. So those features have to be calculated a bit or maybe retrieved from another source to be used in the model. Right. That model is not, of course, coming there automatically. It has to be trained first, and it has to be put in a location where it's available for the API. So some specific terms already come into this architecture already. The model registry. A model registry, think about it as a database or even just an extremely simple file share or so where the model can be stored as a file. Your model can just be a file that is exported to an intermediate format like joblib, for example. The model training is, of course, the process that leads to the model that you can actually store in the model registry. So this can be maybe your Python code that has been exported from your notebook that runs somewhere in a batch process, for example. One step further is that, you see this on the right side, it's very important that your model is retrained. Because a model that's trained once on historical data, it will run in production, it will work, but it will produce the similar results all the time while your customers' behavior is changing. Customers are humans, usually, so they will be interested in different products and they will have different kind of interaction with your application. So what you need to capture is that interaction and the behavior of your customers in actual data. And that actual data is stored, again, to retrain your model, firstly, to make your models even better. So this is basically the feedback loop that should be incorporated in all machine learning systems. And how often do you do this? This model retraining, maybe once per week, once per month, maybe once per hour. If you have this in place as a process, and you can schedule it, you don't care anymore, right? It's not a manual step anymore. It's something that you can schedule. And if this is happening frequently, if this is happening maybe once per minute or once per 10 minutes or so, we call it online learning. We call it an online feedback loop that is continuous. So actually based on your customer's behavior, you're retraining your model all the time, and that makes new predictions. But it's scary, right? Because how do you know that your model is still accurate and doesn't produce results that you don't want? On the left side, another new technology component which has become popular since 2 or 3 years now is the feature store. Because, and we introduced this because the features that we need to train the model they need to be stored. You can just put them in a regular database, but it's actually useful to reuse these features also in your scoring data flow, which is usually real time, right? At least in my example, it is. So this data preparation step that I mentioned before already could actually benefit from features that have been calculated in the past based on actual data about a certain customer. For example, what kind of purchases he made in the past or so. And if you don't have to recalculate them every time, you can just retrieve them extremely fast from a feature store. That has benefits because then your online process becomes faster and more efficient. And also the feature store is a special kind of database because it should not only be able to produce these features fast for real-time processing, online processing, it should also be able to store the historical data of these features. If you calculate the actuals and you compare them, etc., it is also useful to store them in the feature store so they are available when you're training your model, and you can go back in history to check all the historical data points. Okay, that's the core part basically of the machine learning architecture, and there's some other things that are very important as well. I already mentioned if you're doing training of the model, you should always be conscious of, hey, what is happening? How are my predictions behaving? Are they still in a certain, expectations? Are they not producing any anomalies, for example? So rather than just monitoring the technical aspects of your system, you should also be monitoring the business aspects of your system. How are your predictions? Are they not producing any kind of strange results, for example? So in machine learning operations, logging, metrics, etc., alerting is very important, and it shifts a bit from just a technical monitoring to also business monitoring. And finally, all of this code, infrastructure, software, data needs to be, of course, deployed, released in a controlled way. So this is also something that is very important for all software, putting certain quality metrics in place, testing it, releasing software via a CI/CD pipeline, putting things in version control, etc. Well, that's basically common practice for most of the software engineers, but it might be new to data scientists. But it's very important to do so. I cannot go into depth too much, but there are, of course, some specific things that you need to be aware of when you're testing and releasing and quality checking the models themselves. But the important thing is to realize that if you're doing things in a testing environment, then you usually don't test the outcomes of the model. You don't test the predictions, but you test the technical aspects there. And the monitoring and the metrics, and maybe things like A/B testing and canary releases, etc. That's what you apply to check if the model predictions are as expected. So this is a kind of a reference architecture, and I put this, and I spent so much time on this actually because you see a lot of these kind of diagrams all over the place, and every vendor and organization will have its own kind of picture for this. I believe that this one is capturing all of that, basically. So if you see an architecture for machine learning from whatever, Microsoft or Google or Databricks or Snowflake or any vendor, you probably, if you know this, you probably will recognize these components. But of course, they will be named differently, because Databricks will have their own, model training tool. And Microsoft has its own model registry, which is fantastic, etc. But that's not really what matters. It matters that if you that you put these kind of software and database in place, then yeah, you get the overview of your architecture in the right way. So I mentioned it already before. I'm not going to read the entire slide, but this is basically the important steps that I just mentioned already. Now, the final topic is the tooling itself. So if you think about your architecture and you have this kind of in place, then which tools should you be using? Well, I'm not going to tell you which tools to use, so because that's impossible, right? The tools should fit your organization, and there's always, you know, so there's three main, dimensions that I want to give to you to evaluate tools. And even if you know this, it's still difficult. So what I would also advise you is to just start small with something and maybe scale up if needed and keep evaluating your tooling. That's easier said than done, to be honest, because tooling is a very sensitive topic. I work for so many organizations where they pick the tool and there's a few people in the organization that stick to the tool because that's the tool that they know and use. And of course, if you switch to something else, then yeah, they have to let go of that. It's their little baby, for example. It's the thing that they are used to work with, and they invested so many years already in working with this tool. So this is always a very difficult topic. And yeah, that comes down to management, right? To talking to people, to communicating well, stakeholder management, getting them onboarded, etc. So, but going back to the slide, 3 dimensions for selecting tools. The traditional buy versus build. Should you buy something from a vendor or should you build it yourself? I have not found an organization yet that says, we are a buy organization. And I also not find an organization that says we are a build organization. There is always, you know, a gray area, and that's also how it should be, because you should just pick the best solution for the things that you need to do. Sometimes you have a great team that wants to work with open source software and build their own abstraction layers on top of that and integrate it, but they are, for example, only in, let's say, the front end area, but your machine learning team is maybe not so advanced and not so big, and they are more comfortable with buying certain products like licensed products, or maybe installing their software or using a software as a service. Well, that's perfectly acceptable, right? You should be flexible in that sense. And each will have its pros and cons. So indeed, open source, building your own, that is where the innovation is usually. So that's where you can be on the forefront and the cutting edge of your technology. But it also has some downside, because that has to be maintained, so that you have to spend some effort on making sure that you have the right people on board to do all of that work. But it's a choice. On the other side, if you buy software, then you have a kind of a vendor lock-in, as we call it. Yeah, that's also a downside of that. Another dimension is, should you go all in a platform, in a joint integrated tool set, or should you buy point solutions, which are basically best-in-class tools that do one thing very well? Going back to the architecture, I could go to Google, for example, and say, hey, I want to do machine learning. Let's work with the Google platform. It's called Vertex AI. And I'm going to just use all of the tools in your Google cloud environment. Well, that's possible. Google will be very happy to serve you with that. But then you could also say, hey, I evaluated these tools a bit, and I see that I now want to have the best-in-class a model registry tool or a feature store tool. So I'm going to go to one single vendor and pick the solution that is the best, whatever, model registry for that. And I'm going to use that. That's also possible, but then you, of course, have the integration difficulty again. So it's a bit of similar discussion versus buy versus build, but it's a conscious choice that you have to make. And finally, and it's a bit more, it's also, again, related, but it's more specific for machine learning. It is, should you build and train your own machine learning models, or should you use AutoML? And AutoML is also a topic that will be presented later today, so I would encourage you to have a look there. Because nowadays you can actually buy or hire or whatever you want to call it, you can use machine learning models that are just available for everybody to use. You can go to Microsoft, Google, etc., and just say, hey, I want to use your machine learning algorithm that does image classification, for example, or sentiment analysis. And that is usually a good idea, because why would you train your own custom machine learning model and spend all this effort on training and building and setting up the whole tool stack for something that somebody else has done pretty well already, probably. And this is again a grayscale, eh? So I would recommend to use AutoML in most cases for these generic recommendations, like indeed sentiment analysis. But I would not recommend it, and it's also not possible, to make predictions based on your own customer data, because they are unique to your own organizations and to your own products, etc. So yeah, you cannot use a standard model for that. So based on your use case, you should basically be conscious on what direction to take here. And there's a special case for this, and it is generative AI. And generative AI is actually on the side of AutoML at the moment, in my opinion. So think of generative AI as a model that's a train, I think, that is there for you to use. And yeah, you could train your own large language model, or you could train your own image generation model. There's now tools emerging for that, but actually, very few organizations do that yet. It's much more, yeah, it makes much more sense to use the AutoML models, basically, just look at them in that way, from organizations like OpenAI, and Google also is emerging, etc., and do a bit of fine-tuning for them and prompt engineering, which is not machine learning training, right? It's not model training. It is the stuff around that model. Yeah, from one of the first slides. It is the data preparation for those models that you just use as a service from the cloud. Well, maybe a no-brainer, but for all of the tools that we have just mentioned, you can start small and scale up. And this is maybe a no-brainer, but I've seen so many organizations that start with a tool. They start, we're going to do machine learning, and we're going to buy a big feature store or something else. But there's a very high chance that the stuff that you want to do is already possible with tools that you already have in-house, that you already have available, right? A feature store is you can just start with a database. And yes, there are some requirements that you can only solve with a feature store product itself. But to do machine learning, you just recognize that I have to have a database that stores my features, and I can just use my old progress database for that, or so, or whatever I have lying around in my cupboard. And same goes for all of these tools, actually. So I want to mention a few tools that already passed the stage in the reference architecture, because I think there are special cases for machine learning. I'm not going to mention all of the tools like the APIs, etc., too much, but a few ones are, I think, something that you should know something about. Starting with the feature store, and yeah, some options that I mentioned here. I mean, there's many more of them, but some of the leaders in this area are Feast for open source frameworks. Hopworks has a good feature store. H2O, Google. Well, anyway, as I mentioned, that's the choice you have to make yourself. Which tool to pick based on these 3 dimensions. But a feature store is a dedicated database for features. And why is that? Why are there tools for them in the first place? Why just not use a database for it? Because we have so many database technology already. But usually, these databases are good in one thing. They are good in either big data, storage and processing, querying, or they are really fast and produce, lightning fast results for let's say lookups for single queries. And they're usually based on in-memory caching technology, like Aerospike and Redis and those kind of things. But they are 2 worlds apart. So it's difficult to have a database where you can say, now I want to have 5 terabytes of historical data to train my machine learning model, and tomorrow I want to have, from the same database, I want to have 1 record that was just ingested 2 seconds ago, and I want to have it in 100 millisecond latency. Then the database probably says, yeah, that's not possible. So the solution there is to have 2 of these databases and keep them in sync somehow, or to build a caching layer on top of your big data database also somehow. And that is difficult to do. And that is actually what these tools are doing. So the feature store is nothing else than, a database that takes that part away from you. It's basically combining what we call online and offline serving of data. And if you don't need it, you also don't need a feature store. That's also the good part about it, right? You only need a feature store if this is your use case. If your use case is offline retrieval of large data sets for model training, combined with real-time data retrieval for online serving. The other tool I want to highlight is workflow orchestration. And maybe a no-brainer, but a lot of the work that you need to do in a machine learning environment is batch-driven. Actually, some of the organizations that I work for example, only do batch. There is no real time, there is no streaming, etc. Maybe they want to, but maybe they're not there yet, or maybe their use cases just don't exist yet. So batch is very important, and all these batch jobs, it's a good idea to manage them well, to orchestrate them well. You could also just write, shell scripts, or write maybe Python scripts or so for that. But it's usually a good idea to put them in a kind of a tool where you can manage them, you can stop them, you can have them, you can have proper logging and management of them, you can integrate them, you can schedule them, etc. So it's a good idea to invest relatively quickly in a proper workflow orchestration tool. Some options here, and they all have their pros and cons. Airflow is probably the most well-known. It's a generic tool that does a lot of things very well. It's also a bit older, so it's maybe not so user-friendly or intuitive to use, but in many cases, it's already the standard for many organizations. And if you have Apache Airflow running anyway, why would you not also use it for things like the batch jobs that we have in machine learning, like feature engineering, model training, etc. But there are also some other tools now arise with a special purpose that you can also consider. For example, Kubeflow. It's Kube from Kubernetes, so it's offloading your workflow orchestration to Kubernetes. Airflow can also do that, by the way. But it's more specialized for machine learning tasks. So it has already out of the box great capabilities for like a model training and experimentation. Another one is MLflow. It's also a great open source tool for doing experimentation with the machine learning models. So just selecting some data, grabbing it, and retraining a model and see what the outcomes of that are. So depending on your needs, this is something you should consider in depth. Yeah, and then finally, I want to, because I cannot come here with a presentation without mentioning generative AI, right? This slide needs to be in, because else I will probably not be taken seriously anymore. So anyway, generative AI is still very new to basically all of the organizations. I mean, since this is now actual since a year or so, most of the organizations that I work for now are just getting started with this. They just have a hackathon or an experimentation or so, and not really putting it in production yet. But it is important to consider because, of course, I get a lot of questions about this. What about generative AI? How do we do this? How do we build our own large language model? Well, I already mentioned, in my opinion, treat this as, yes, it's something new, it's something special for a lot of organizations, but just treat it as an auto ML model. Treat it as a model that you can pick out of the cloud, do a bit of fine-tuning and prompt engineering for this, and then just treat it as such, and then you're fine. Model serving, I didn't put any specific tools for this or services for this, but the way that models are served, so how they are put in production and API-ified as well, you have a few options for that, and that's important to realize. What you could do is actually package your model, so that's your file, together with your business logic and API into one big application. Because your model might be just Python code, so why you'll just put the code somewhere alongside with all your other code. But that's usually not such a good idea. Why? Because your model the changing frequency of your model is usually different from the rest of your application. Because your model is being retrained, so it produces different results. It might have different features, etc. So it's a good thing to loosely couple that, as with any other software, right? Microservices, etc., exist for this reason, because things change in different frequencies, and if things are smaller, then they're easy to maintain and deploy and test. So making things modular is usually a good practice. So what you could do actually is put your models in a shared service. That's a common approach, like a dedicated tool that, for example, MLflow again, we already mentioned that, where your models are available for you to use. And you can build and train and update your models one at a time. Yeah, that's a perfect solution for that. Another solution that goes a bit further in modularization is actually to just write a small wrapper around your model and just put that in a single API. And so basically making a microservice of your model. And this is a very common practice and something that I also would recommend doing. Just write a thin layer on top of your model, package it together, and make sure that you deploy it as a unit, as a microservice. And in a final special case, if you're doing streaming data analysis, streaming data processing, and you also want to make use of machine learning models in your stream, then doing the other option, like writing an API that you access across a network, retrieve the result, do serialization, deserialization, because that usually happens when you call an API. That might actually be too slow, because your stream might, you just have to respond within only maybe 100 milliseconds or so. The use case, for example, for fraud detection, if you're making a payment with your credit card or your debit card, and the bank needs to check immediately if this is illegal or not, and they might want to block your transaction within half a second or so, then the call to your model that makes this prediction, whether this is a fraud case or not, probably needs to respond within a few milliseconds. And then going across the network and doing all your stuff might be too slow. So what you can do then is package your model in your stream and actually broadcast it, as we call it, in memory in your stream processing engine. And that might sound a bit far-fetched, but there's tooling available for you to use and to do it exactly like that. But you come into some specialized frameworks and data formats like PMML and Onyx that basically export your model to these formats that can be readily distributed in memory across your data stream. Okay, that's it. I told you all about MLOps that I know. The takeaways are, the notebooks that these data scientists are writing, they're great, but that's just a starting point. And so treat them as the beginning of your machine learning system in production. MLOps is actually DevOps, but then extended a bit. So MLOps is not a tool. MLOps is a culture. There's no silver bullet, right? All these tools that I mentioned, I mean, there's no single holy grail or silver bullet that does, that magically makes all your machine learning problems disappear. Yeah, you really have to put some effort in selecting the best tools and integrating them in the right architecture. Start small, scale up. We mentioned that already. And I told you a bit about the reference architecture for machine learning and some tooling options and considerations that you need to be aware of for this. If you want to know more about this, some recommendations on reading. There is actually books and blogs and that also cooperated in. There's actually also Coursera has a specialization for MLOps now, which is pretty good. So you can do online experimentation with this, based on some models in, like, for example, TensorFlow. So they have the whole data science within it. So also recommend to do that. And there's there's the MLOps.org website, which is vendor independent, which I always find important to realize about these generic concepts. So thank you very much for your attention. Thank you.
Okay, so we have some time for questions. Let's not waste time. So first from Kubo, what is your top choice for feature store tool?
So I just had a whole story where I said I'm not going to recommend any kind of tool. So I'm probably not going to do that. But let's say if you're an open source lover, then Feast is the best option. And if you're not, then probably Hopsworks has the best feature store at the moment. But I also want to give a special mention to Google, because they recognize this as a big topic, as by the way also Databricks, Snowflake, etc. And Google announced 2 weeks ago, I think, in the Google Next conference, a new breed of their feature store. The old one is, well, it's okay, but it's not top notch. Where actually a lot of new, they improved so many things in like performance and API and documentation, etc. So that's also really good to keep an eye out for.
Okay, next from Nino. If one has limited time, we all have, which parts of the MLOps cycle would you recommend spending the most and least time on? Which parts can be delegated?
Yeah, that's a really good question. Let me think about that. I would spend definitely the most part on things that matter, and what matters is model training. So let's face it, if your model accuracy is low, then all of this is for nothing, right? So that's where your effort should be, definitely. So that means investing in a good tool, in good people to do that, and basically structuring that in a good way. The things that I would probably be least concerned about are things that that are generic, and that is maybe the batch processing that you just have to do. So that is setting up the tooling, for example, to do batch management, etc. Because that is something that is, well, it's not it's not universal, so, but it's something that probably already your organization has some experience with. So that's something that is, least of my concern.
Thank you very much for your answers. These were time for questions. I would like to give you one more thing. This is you.
Oh, wow.
Nice
Thanks.
drawing, and also some tea for cold winter nights. So please take it home back to the Netherlands. Another big round of applause, peace to Bas.